This is Cosmographia, the Randall Carlson Podcast. All right, welcome back, ladies and gentlemen, to Cosmographia Podcast. We have a special guest with us today, George Howard. He worked in the U.S. Senate for 6 years. He is an avocational scientist. He is a director of the Comet Research Group and co-author of the seminal paper in the Proceedings of the National Academy of Sciences in 2007 titled Evidence for an Extraterrestrial Impact 12,900 years ago that contributed to the megafaunal extinctions and the Younger Dryas cooling. He has been involved in this research for 20 years. Owns a company in Raleigh, North Carolina in the environmental mitigation business, and he runs the Cosmic Tusk website and blog. George, welcome to the podcast. Thank you for coming on.
Thank you, Snakes. I'm also a big fan of you guys and very much appreciate hearing y'all's words as often as I can on podcasts. Big podcast fan, and you're leading the way.
Thank you. Thanks so much.
I love being with you on the Edwards Plateau. I love where you live. I'm not sure whether I could stand it out there with the scorpions and all of that. Yeah. But to see the night sky like you fellas see it is a special thing.
It is.
Yeah, for sure.
Yeah,
it is. Randall, Brad, how are you guys doing this week?
We are, well, I can't speak for Brad, but I'm doing quite well after a few harrowing weeks there with personal kind of tragedies going on.
Yeah.
I told you guys about that kind of took me off the rails for a little while, but I'm back. Everything is in context now and in perspective, and things change and we move on. So,
all right. Well, I think this is going to be a great show.
I'm getting better at juggling all the chainsaws and the hatchets and axes that is life at this current time. But yeah, I'm good. I'm getting better at it. Welcome, George, man. We've been building you up for like 5 or 6 episodes. So
right.
Today's the day. We're happy to have you, man.
No pressure. Hey, I'm happy to be here, and I'm glad to see you guys coming together. You don't know what's going to kind of metamorphosize out of all this information, and to see, you and Randall have always been a pillar of it, and then to see the Snake Bros come on, and then to be able to come on to it's really exciting. I think it's a good format, and I think we can get some good information out there from different perspectives.
Excellent.
That's the plan, my man. Glad to have you.
Yeah. So last week Randall, we went through some more of the megafauna that went extinct. We went through the some of the fossil sites, like the one in the kettle bowl or kettle hole out there, and then we talked about some of the criticisms that have come in from people who support the overhunting hypothesis, and that's where we left off. But I think George is going to take us up to 2007 and beyond. Is that right, George?
Yeah, I'll go anywhere Randall wants me to go.
Okay.
He's driving the ship. But I tell you what, Randall, it's a real pleasure to be on here with you particularly, sir.
Oh, likewise, George. Yeah. I've been looking forward to this and thinking about this for a couple of years now, actually.
Terrific.
Just didn't know when the first venue or opportunity was going to show itself.
That's great.
Yeah, we've done a couple of episodes out in the field now where you and I have been out there together.
Yeah, it's great.
Hopefully do a lot more.
That's right. We have gotten together in the field, me, you, and Brad, and we both played a role in Graham Hancock's recent book. Yep. And we had you to Wilmington, North Carolina, and had an interesting little scientific session there, to say the least. Came a little controversial, but I think instructive. About how with even our own community there can be fractures between what people believe, our own community being catastrophists. But it's a big subject with not enough information, and we're all entitled to disagree. I think you and I are probably a little bit more on the speculative side. You even more perhaps than I am, but I can explain the perspective I come from and how I got into this debate whenever you like me to.
Yeah, well, we definitely need to go there. Absolutely. So I think that it would be good to go back to that 2007 paper because I didn't know you when that paper came out, but I can still remember how excited I got when that paper showed up in the scientific press. It was almost like, well, Brad will testify to this because we had been talking about this together for, close to 10 years, literally.
Right. I know you had.
So yeah. And pulling these kind of more tentative strands together to come to
Right.
this conclusion. And then suddenly here's scientific vindication. But what kind of came as a shock to me, I guess, was the response to it that you've mentioned. And I think that's because it almost seemed like there was I wouldn't even know, I would say almost an irrational response to it. Like there was a faction that just didn't want to even consider or go there as a possibility, and immediately began to invoke whatever explanation could seem to offer an alternative to the idea of something from space hitting the Earth. So
Well, I think what you welcomed in 2007 is the same thing I did, having already been a catastrophist, if you will, and people can look that up. But I think the listener of this podcast might understand that some people believe that Earth's history, in fact, human history, is punctuated by tremendous cataclysms.
Yes.
So that's the first definition of a catastrophist. You and I and Brad all held those views long before that 2007 paper. I was one of the lucky people out there on the internet in the 1990s, or I guess the only one, that got contacted by the original credentialed scientists who had found similar evidence that had been, I guess, circumstantially provided by catastrophists like ourselves, that followed up and actually looked and said, can we look at these soils, old, well-dated archaeological soils? And that's the tremendous hack of this scientific team that I'm lucky to be part of, is they said, we're not going to argue about the dates, although that's come to be over the last 15 years. But most of the dates of the original sites are indisputable, that they'd already been well published by other scientists for the last 50 years, like Murray Springs and Blackwater Draw and places like that. So what the Comet Research Group did prior to 2007, which came to fruition in 2007, was said, let's go back to some of these well-dated sites that are well accepted by mainstream archaeology and other geoscientists as being a particular age, and let's look at the soils right at that band where you transition from the well-accepted dramatic change from the Pleistocene to the Holocene.
We left off last episode actually with the black mat.
Did you? That's great, because it's
that's a perfect point for you to pick up the narrative.
Well, it is, and the black mat was the place where perhaps mankind picked up its narrative.
Yeah,
it was a profound transition, even according to mainstream scientists. That's what's so important to first know, perhaps for your viewers, that for at least 50, 60, I was looking the other day to see the first published reporting of there being a dramatic transition in kind of regular scientific literature. And I found it all the way back to 1898, where someone, a European scientist clearly, has said that when I go back through the soil layers, I find something dramatic happened roughly. I don't know whether he dated it correctly, because they certainly didn't have C14 dating, but he said there was a dramatic change 1.5 meters down or 2 meters down or whatever in my local soils. And then you follow it all the way through to the well-defined Usolo soils in Europe, which started to be discovered in the 50s and 60s and set in the sand covers in particularly the lowlands in the Netherlands and Belgium and whatnot, that you can find a dramatic transition. And then bada boom, bada bang, into the 20th century, they're finding the same dramatic transition in soils in North America. And then we're able to date them. And then we're able to see that that's where the first human culture, I have a little show and tell, the Clovis people, you can see there. And that's not a real point, though I wish it were, where the makers of this technology blinked out of the archaeological record. Not coincidentally, that's when the large megafauna blink out of the archaeological record. And not coincidentally, that's where we find a distinct change in the hydrology and surface conditions that resulted in a black mat. I need to note the black mat itself is not like burned material that fell out of the sky. There are things like that, carbon soot, and they call it a ceniform soot, and exotic kinds of soot that they can connect with these kinds of global and regional conflagrations. But that soot actually shows itself at the bottom of the black mat. The black mat was the change in the hydrology and the climate conditions, and was basically a very, very dark time on the landscape, both from a soil perspective and from a climate perspective and from a livability perspective, if you will. And that shows it. But when they tested below that black mat, immediate below it, the lead authors of our papers discovered that it was enriched with proxy materials from what was apparently an extraordinarily widespread high heat, high pressure hell event that occurred very, very suddenly. And it's only after that that you don't find either the Clovis people, I've got a couple of more, the mammoth, our friend the mammoth, that's a mammoth tooth. Yeah, there's the old, had to bring in the cave bear tooth. Kids love that, you know, and you spit it out for the tooth fairy. Give that guy a
Nice.
cave bear tooth. But that megafauna disappears along with that first human culture. It complicates things because that human culture, as you guys well defined in earlier episodes, is implicated in the demise of those 54 genera and 258 different species of animals. Somehow they chased down to the very last of 2 different kinds of birds and a 2-ton armadillo and ate every single one of them. Y'all have well discussed this, so we don't need to plow that ground again. But I don't think that the coincidence between this disappearing and this disappearing is causal between the two, except perhaps in a post-catastrophic situation, or perhaps in bringing the populations down somewhat before the cataclysm happened. What's really at fault is this, and that's a meteorite.
Nice.
And I probably shouldn't say that because we actually believe it's a comet, but the line between meteorites and comets is a constantly shifting thing, as Randall knows, and you know, Brad. So you hate to use them interchangeably, but it kind of works. This is an iron meteorite, which is now suspected to be perhaps involved with the cataclysm by other scientists, not our group. But I won't get off on that quite yet. So
we're transitioning. Sorry, between the A word of Atlantis and the new A word where we're going is asteroid.
There you go.
You bring that up and people just veer off immediately to the left. They don't want to hear that. So it's kind of get the same response as Atlantis if you bring up asteroids.
Oh, wow.
I think those responses are unfortunate, but I have to be honest, I'm glad I missed the Atlantis episodes because we got enough on our hands with this cataclysm. Okay. And that's really important to know where I come from, because I will not even say halfway. Well, I'm a director of the Comet Research Group, and that's about 65 PhDs in me. Okay. And I'm not a credentialed scientist, but I'm a loudmouth.
Useful.
And I hope a responsible one to some degree, and we can get to some of the things that I think we've done to add utility to the debate, like our bibliography that's available at the Cosmic Tusk. That's a pure utility where I'm trying to bring some utility to the group, other than occasional field collection and kibitzing. But
excuse me, George. I hope we can get back to it eventually. You know, you're going to be on with us, I expect, multiple times. Back to where you were one of the original people on the internet as far as discussing the Carolina Bays. And the Carolina Bays really is what led Randall into wanting to explore the Missoula and the other Ice Age floods, which is when I got involved back in '98 when we made our first trip out to the Scablands. So it's interesting that you were putting that out in those years, 20 plus years ago. And that's the same time Randall and I hooked up and started studying those same things. So yeah, eventually we'll get around to letting you tell those stories of those origination points.
Yeah, I can pick up in 2007, which is the modern iteration, where the Carolina Bays, as the snakes know, became the kooky caboose of the theory. Okay? And the train had a lot more information it wanted to drag down the tracks than carrying along the Carolina Bays. And that's humbling because that's the way I got into it. But it's also justifiable because the Carolina Bays are still rank controversy, and they should be. There is no acceptable explanation. We've added some to the debate that I can give you, but even as somebody whose name is connected with it, and to what Brad's referring to is in the late 90s, actually put a paper up on the internet at georgehoward.net that sits up on the Relic site with the HTML breaking down as we speak. The Cosmic Tusk has long eclipsed it for me. But and I have a reprint of it on the Cosmic Tusk. I wrote a paper for a friend who was in college, or helped him out with it, and then posted it because I was fascinated by the phenomena on the web, and my name became connected with the Carolina Bays. And that's why some of the scientists that were first investigating whether there was a cataclysm at the Younger Dryas boundary contacted me because the Carolina Bays looked to them to be anomalous too. Did it end up being the best evidence? No, it certainly did not. And the evidence probably shouldn't be brought into the courtroom now. But it's still a fruitful area of research for me, for you, for any of your listeners or watchers. The Carolina Bays are a great and fascinating thing and still need an answer. And they potentially are connected to the YD event. Some people would say they aren't potentially. But I still, leave open very much, and I know some of the publishing scientists do, that they are connected, but it's simply not the best evidence. But I'm happy to tell you how I got in the Bays, or I could pick up at 2007 when they started publishing the papers, and I joined the first one. We went down to Acapulco, so I can go anywhere with that.
Oh, I guess why don't we go with the 2007, and then we could always backtrack into the Bays because people might want to know. I've noticed a lot of comments and things over the last year or two. People are interested in learning more about the Bays. When is he going to talk about the Bays? So I've sort of almost deliberately avoided getting into the Bays, other than a mention here or there, because when I do, I felt like it was going to be important to go into enough detail so that people can see the different sides of the argument. My Bay exploration started with Henry Savage's book, which I think
exactly right.
Yeah,
1982.
Yeah. I think that was about it. Yeah, I think it was been maybe out a couple of years by the time I'd first discovered it. But, when I did, I thought, well, hey, I'm in Georgia. This is right in my backyard. This is interesting.
Yeah.
And that was an important phase in my thinking. And as Brad just mentioned, it was the idea that, the orientation of the Bays, perhaps assuming that it was an impact or a fragmentation event or some variation of that.
Right.
The Bay, the axial alignment of the Bays is suggesting something coming from the direction of the Northwest.
That's right.
But with the limited access I had then, because I didn't know at all about the Nebraska Bays, for example, that have been now factored into the equation. But tracking that roughly 45 degrees to the north, that's when I realized that, well, if it was an incoming bolide or object undergoing a fragmentation event, it passed over the Laurentide and Cordilleran ice sheets.
That's right.
Is there anything to suggest something unusual in the deglacial process? And as soon as I looked into that, it was like, oh my God, it was just like a tsunami of stuff. Yeah. Oh, totally. There was.
That's awesome, Randall. Yeah.
So then it becomes the question of, well, all right, is there a connection between the Bays and the melting and the potential idea of something from space?
Right.
And it's led into, and of course, by the time Henry Savage's book had come out, I was already obsessed with the KT extinction event. Right. Which, of course, there were important papers that came out in 1980, like three of them, that kind of turned the tide, I think, in the acceptability of thinking about catastrophist ideas.
Oh, I think everybody would agree with you. It's just how far you take it, and they're resisting the next step. That I've always believed that the 1980 discovery is almost like a reverse telescope, if you will. It's a pained analogy, but you're looking out there, and for some reason we discover the things that are further from us first. Mm-hmm. We discover the most dramatic event of all time within a certain range. And then as our forensic techniques get better and better, we're able to resolve some of the more subtle events in the nearer times. Mm-hmm. And the first one of those to resolve was the Chesapeake Bay crater. Mm-hmm. You thought I was going to say the Younger Dryas event, right?
No, I would, So that takes us back to the Eocene Oligocene time.
That's right. And that's 35 million years ago. So then you cut the difference between 65, it gets down to 35. You have the Chesapeake Bay event, which changed the course of rivers all up and down the East Coast and had dramatic effects. They still don't have good well water anywhere in southeastern Virginia because it fractured the rock so completely.
Splattered Georgia with a tektite field.
And splattered Georgia with a tektite field, which is absolutely amazing. Yeah. And so you imagine how hard it was to prove that we had the dinosaur extinction at 65 million years ago until they found, fantastic evidence, through some great sleuthing, scientific sleuthing by drilling and using oil and gas information and whatnot. And then that overturns that. And then just years later, an ambitious scientist, I forget his name, at the United States Geological Service that was in the regional office there in the Chesapeake.
Wylie Pogue.
Wylie Pogue. Thank you.
Yeah.
It's got a great name. Exactly. Randall, you're a great archivist. Wylie Pogue kind of had to fight the good fight again and say that, listen, something happened 35 million years ago. So then let me zoom forward. What's the next biggest thing that anyone ever proposed? And the one that definitely got, spat back by some quarters was that, holy moly, 13,000 years ago, something happened that resulted in extinctions and dramatic Earth effects. And it's kind of interesting that we found that later than something that happened even deeper in time. But let's look at the difference let's look at a time scale from us, the dinosaurs. I found this helpful explaining this to friends and family before, that because everyone's aware of the dinosaur comet, right? Mm-hmm. To some extent.
I hope so. By
so
now.
65 million years ago. This is 13,000 years ago. That's roughly 3,500ths of that time frame ago. Mm-hmm. So if I'm sitting here in coastal North Carolina, and say Raleigh, and I draw there's a road, I-40, that goes all the way out to Barstow, California. It's 3,500 miles long. Okay. So if you stick the dinosaur thing out there in Barstow and run it to Raleigh, this event's at the 7-Eleven I could walk to in 15 minutes. Mm-hmm. Right? It's so much closer. It's so more tangible, I think, to the public if this all proves out, and it's well on its way. But it's going to have a much more dramatic effect on the psyche when they realize the difference between those two events. The mammoths, to probably a lot of people, and this attribute it to bad education, might seem just a step away from the dinosaurs. Hell no, they weren't. The mammoths and the saber-toothed tigers and the giant ground sloth and the glyptodon and the other 256 species that went extinct in that time period, not on that day, and that's important, but in that time period, as a result of that very bad day, that they're much closer cousins than a damn dinosaur. A dinosaur, to me, God bless people who found them fascinating. Obviously, they are to some degree, but they might as well be on another planet. That's deep time. That's not particularly relevant to our development of a species, as a species. Then you look, or our development culturally, and then you look and say something happened 3,500 times more recently that was at least on a global, well, we now know a global scale, just like the dinosaur killer, and we were there to see it, and we were modern Homo sapiens, and we already had art at that point for 25 or 30,000 years at least, and that's mainstream science, that we had art. Yeah. The disputed part is how high the civilization was, but it had some beautiful art. The Denisovans had their bracelet. That bracelet that was found a couple of years, unbelievable. 30,000 years after that, something happened, and that launched us into the age that we are today. And one way or another, those things conspired. That terrible 1,200 years of the Younger Dryas that occurred after the impact, in our opinion, that solidified a certain human approach that required, in my mind, kind of fighting back. That we couldn't just pluck pears, we had to pull plows. Right? Yeah. So plucking pears to pulling plows happened to coincide with the time that we're finding abundant proxies for a high pressure, high heat event in well-dated archaeological soils.
Let's talk a little bit about some of those proxies, so people understand. Let's have some examples.
That's right. And go ahead. It plays right off the dinosaur killer science.
Well, it does, because nano-diamonds that have been found at the black mat layer are being compared to nano-diamonds being found at the KT boundary layer. And in fact, the diamonds at the KT boundary layer are the closest analog to the diamonds found at the Younger Dryas boundary layer, which I find interesting.
Randall. Yeah. And it's that aspect, the matchup between this was acceptable. It took us 14 years to prove, it's certainly not us. It took the Alvarez father-son team 14 years to prove that their 1980 paper saying that the KT boundary was enriched in iridium and had other things that suggested there was a catastrophe. It took them 14 years to find the crater and, let's say, get it into the classroom. Well, and that's minimum. It really took about 20, but let's say it took 14. If you look at the forensic techniques they used, one by one, they've all been used in the Younger Dryas impact. Except for planar features in quartz, and you know what that is. We can go through explaining that. That's a little controversial, but that is probably likely to be associated with some of the stuff that we're finding that's been discovered in Greenland. That story and done. But if you take some of those same proxies, including geochemical markers, enrichments with platinum group metals, right? Iridium, and in our case, platinum.
Platinum,
an enrichment that's multiple times, sometimes 1,000 times higher than what they call the average crustal abundance that you're to expect at any place. And if anything isn't well within a range of error of that crust, you know that there was enrichment that came from somewhere, and they know that enrichment came from space. So that's a set of markers. Another set of markers are magnetic, metallic, and silicate spherules.
Right, silicate spherules. So that's a good one.
That's exactly right. And those are all the frozen mist of the vapor of the moment of hell.
Yes.
Where rock material was vaporized, thrown into the sky, mixed with material from the impactor, and then comes back as literally frozen little tiny spherules of mist. And you can look, and maybe you can pop up a visual.
I will.
And I'll work on my end. You take the screen. I think we both got some that show features that included. It's funny how things scale from large to small. You can see on some of these spherules of frozen mist where another spherule of frozen mist that had frozen before it impacts one and leaves a crater on it. And sometimes those craters will be measured in nanometers.
Wow.
1,000 times smaller than the width of a human hair. So those little things are interacting in a similar way that we see the moon interact with impacts, but on a much smaller scale. So when you look down at that mist and see that those little bits were hitting each other and that their component metals couldn't be liquefied until it's 3000 C, and you're finding that in 100 times abundance of anything above or below it at an archaeological site, you know that a mist of molten rock fell in that at that time.
Yeah.
So that's a proxy. There you go. Thank you.
I'm pulling up a visual here.
Yeah.
This is Younger Dryas boundary spherules displaying some of the wide range of surface microstructures indicative of melting and rapid quenching. The top three are from the debitage layer at Topper. The middle six are from Blackwater Draw. And the bottom layer is from Paw Paw Cove.
That's right.
So you notice, that surface texture can be really smooth, but it can also be very mottled looking like this.
That's right, and that's quenching, as they call it.
Yes, that's the quenching. How rapidly and if there's a lot of moisture in the atmosphere, it could affect the process of crystallization. But this is a whole variety of these types of microspherules that have been found at that Younger Dryas boundary layer. This is actually from one of Malcolm's papers, which I consider to be also an extremely important paper, because this was Malcolm and his team did the title of the paper, Independent Evaluation of Conflicting Microspheral Results from Different Investigations of the Younger Dryas.
Which was an absolutely critical paper, which is available. Well, I've got to do a pitch here. That is available.
Please do.
On the Cosmic Tusk as paper number Oh my gosh, I shouldn't have assumed that I'm going to be able to find it. Where's LeCompte in 2000? LeCompte Independent Evaluation, paper number 106, if you will, on the Cosmic Tusk bibliography, which can be reached with one click in the upper right of the Cosmic Tusk website. And I'll make that, I'll share my screen. I'll give you another one now, another proxy. And this is one that probably isn't as well discussed because it's not as strong on evidence, but I'll tell you why it's stronger than a lot of the critics think. And what I'm going to do is take over the share if I can, Randall. Boom.
Well, we'll all be waiting patiently.
No, we're not gonna have any tech glitches here.
Here we go.
Here we go.
Oh, beautiful. Yes.
Okay. Well, that's magnetic spherules, and that's what you were just talking about. And
Yeah.
actually, there's a little bit. That's how they obtain them. It's actually not terribly difficult. It takes a lot of sorting into getting out all the silicates and all the organic matter, and then you swipe it multiple times. I have not done the process myself, but I've watching it being conducted now by some students down in Georgia. But eventually you get down to that. You get one of those strong that pulls that stuff out. You're getting those little balls. Those are some of the big ones. But what I was going to show you is the carbon spherules. And then an interesting paper came out in 2011. Actually, I should have said a devastating paper. The carbon spherules were a big part of the thing after 2007, as were the nano-diamonds, as were the magnetic spherules and the silicate spherules and the high levels of carbon and the high levels of platinum group metals, right? So you had this suite of stuff. The carbon spherules weren't, I do not think they necessarily played a part in the KT boundary. They're a little bit of an outlier, so you weren't using that exact same science. And then a paper came out by Scott et al. In 2011 and said that we had misidentified these carbon spherules, that they were actually bug poop. Okay, and that makes for a great headline, first of all. And it became one.
Yeah, I do remember that, yes.
That's right. And it was a terrible, terrible day and blow for the Younger Dryas impact hypothesis, because we knew better. And we knew better because they, Scott et al., and that could be found, can't give you the citation number right now, but it'd be found, I think, 2011 on the bib, came out with the paper, said it was all bug poop, and it was reported worldwide, Ice Age catastrophe hypothesis, it's all bug poop.
Yeah, right.
It makes a great headline.
Of course.
Okay, you go back and look at the actual paper, and I'm tempted to bring it up, but I won't be so tedious. First of all, it looks like they typed it over a long weekend eating pizza, okay? And they did not, the fundamental thing that they, you can see the quality of it versus the forensics that were being done on those spherules in the 2007 and later papers was clearly inferior. And here's the clearest way to look at it. They were looking at the spherules that they looked through other materials and said, you can find bug poop that looks like this under an optical microscope, that looks something like it. But then what we had done, the whole point of listing them in there is the nano-diamonds were found in the carbon spherules. And if you think bugs are crapping nano-diamonds, I guess you're Scott et al., right? It was more profound than that. First of all, their analogies the photographs weren't that great. They went down and said, yes, you can find honeycomb structures and carbon structures that come from animal poop, right? But no, these were unique out of that kind of, formation, that it looks somewhat different. And also, when you study it under a transmission electron microscope, where you're looking at the atomic level, there are a number of unique properties, including an abundance of nano-diamonds.
So is that what we're looking at here, George, on the share?
Actually, you're not. I can call up Scott et al. That's this, and you're looking at a closer take on that.
Okay.
I'd have to call up Scott et al. To show you their photographs, but they didn't go down to the atomic level, and they were using optical microscopes. So that's my takeaway on just that paper. I'm not trying to beat it up too terribly and single it out. There's a lot to choose from. But the critics used optical microscopes, and the proponents, if you will, were using transmission electron microscopes. And that kind of like quick and dirty refutation has haunted the hypothesis from the beginning. And it's particularly torturing to geeks like us, because you can go read one of their papers, and people can now do it at the Cosmic Tusk in the bibliography. You can go one after another and read one of their papers, read one of ours. Here, I'll pop up the bibliography. And then you can see, just as we've been discussing, that was the first paper. We presented that down in Acapulco. It's really neat. And
you got to do a separate share if you're going to show us something else.
Oh, excuse me.
Yeah, so we're still looking at the picture of the carbon spherules.
Yeah.
Kyle just into that share, so.
Okay, and then I'm going to pop on. There's the bibliography right there.
And you, George, you said that was a quick one click off of your main Cosmic Tusk homepage?
That's right.
To get to the bibliography. Yeah, perfect.
Yeah, and I think y'all can still see that, or are you stuck on this? But if you go to the Cosmic Tusk bibliography, you can click into any of these, not those initial posters, but there's the original paper. So if you click there, it takes you straight to it.
All right.
At possible risk of copyright infringement. Okay, but I'm willing to take the hit.
Got to get that data out there, man.
You do. You honestly do. Okay, so I'm scrolling on y'all right now, right?
Yes.
Yep. See it.
There you go. So posters are presented at conferences where you discuss with your colleagues what's going on, and it's somewhat tentative. So we don't have all the posters presented, but we have each and every one of the peer-reviewed papers.
Yeah.
And this is categorized to supporting, critical, and refuting. So supporting is, we believe that there was a tremendous catastrophe 13,000 years ago that wiped out the megafauna and changed the course of human history. And then refuting is saying, hell no, you didn't, you screwed something up. And then we're coming back saying, well, we found some more evidence here, and then back, and then you'll have somebody that's another critical, and then you'll hit some here that flat out refute it, that actually go, and those are coded in kind of a purple there, kind of a plum.
I see the green is for, the yellow is
the green is for, the yellow is kind of, you got a problem.
Yeah.
And the red is, we found something that refutes your hypothesis.
Right. Nice.
Okay.
Well done.
So as you move through it, you can see, to use the absolute most overused word of the 21st century, a robust debate. Right? This is a robust debate, and it is constantly, although there's a lot of clickbait headlines that suggest that we're on the right track. If you get any kind of deeper read from science journalism and the science communicators, as they call themselves, they say that this was immediately refuted, that the 2007 paper and its findings were immediately refuted.
Of course.
And I don't see a refutation paper till the following year. Then I see us bringing in other data, all of it published. If you see over here on the right, at that time, our lead journal was the Proceedings of the National Academy of Sciences, and with Nature and Science as one of the three big publications. And this is a little interesting in the history of catastrophe, and that's why I know, Randall, I appreciated you sharing when you saw that original 2007 paper, how excited you were, right? That you said, holy cow, somebody has a full-throated catastrophist evidentiary claim that they've gotten published by, in the Proceedings of the National Academy of Sciences. That's almost unheard of. That brought catastrophism in man, in the context of human history, prehistory, if you will, but at least while humans, modern Homo sapiens, were walking the earth, that's the first time such a claim had been made in any scientific publication. So
I will vouch for that. That lit a fire under Randall's butt there. Decided when that came out in 2007, no doubt about it.
It added support to what Randall had been saying for more than a decade before.
Absolutely.
And it also, lit a fire under long dead, claims that go all the way back to, if you will, Ignatius, Donnelley. They weren't right about the details. Of course, before that, Donnelley was a congressman in the 19th century. But I hate to say it, the V word, Emanuel Velikovsky, that was so tremendously controversial and a big part of the 50s and 60s counterculture. A lot of people believed in Velikovsky, didn't you, Randall?
Well, let me say what I think about Velikovsky. He wrote a number of books.
I'm not backing him up.
Right.
I want to distance myself a tad. Okay.
Let's say this about Velikovsky. There were different components to his work.
Yeah.
What he did, and I read, I think 3 of his books probably in the early 70s, right?
That's right. My generation was reading them.
Yeah. Mm-hmm. Yeah. So he had his catastrophism and he had his astrophysics.
Yep.
Astrophysics made no sense at all, but his catastrophism, what he did, the book Earth in Upheaval, is still a great compilation of what was known in the 1950s about what was already documented in mainstream scientific literature at that point, that was implying, if not stating directly, the reality of a catastrophe. He also drew upon mythological sources, which was which in the 50s, there was a totally, you didn't have this idea that there may have actually been legitimate history concealed within mythology and legends and so on. So his invoking of mythology and legends and folklore, which of course is full of catastrophism when you look at it, was really used to discredit him. But what he did was he did this compilation of catastrophist geology and paleontology and archaeology, compiled it into the book Earth in Upheaval.
Yeah.
Which I think is still a great source for what was known at that time. Then he went into attempting to explain or to come up with a theory to explain the catastrophism. And that's where he kind of went off the rails. And pretty much the baby got thrown out with the bathwater. You know, there was that book that came out, Scientists Confront Velikovsky.
Yeah.
When I read that, I realized, okay, they're pretty much focusing exclusively on his astrophysics. That, I'm sorry, doesn't make sense. The idea that Mars and Venus were, you know, ejected from Jupiter, came, you know, within a hair's breadth of the Earth 3,000 years ago, or whatever the dating was. None of that really made sense. But his catastrophism collection still, I mean, it's still a valuable source. And so
it is. And all in all, it's hard to say. He might have hurt things. You know, he definitely took it too far. But then again, it's revealing of how resistant 60, 70 years of science still is to catastrophic ideas.
Well, especially when you bring it to our own
points, and we're going to toss out his strong points. And Carl Sagan did that. Carl Sagan, God bless his soul, you know, executed Velikovsky, you know, on tape. And you can see that on YouTube. You know, he took him down in the early 70s, and there was probably some of that stuff was nutty enough to take down. But it also stained the study of catastrophism up until Alvarez came out.
Yes.
But going back further than that, you know, like I was saying, it lended support. The 2007 paper is the first time it made it in. It goes all the way back, I said, to, you know, Donnelley and, you know, then to Newton and Whiston. You know, at the very beginnings, you've detailed all of this. Anyone that's watched your stuff, Randall's going to know of this history. And then, of course, back to Plato. And the 2007 paper, with absolutely no coordination with Plato himself, we consider him an independent worker, notified us of the same important time period in 250 BC. So this idea has been kicked around a bit, folks. And it took it to 2007, until modern science was willing to push something so heretical to them, but so understood and accepted by various thinkers through thousands of years. So we have a long, long tradition whose last chapter almost seems like a new book, but it's just another chapter. We just got to put the narrative over the hill now. It's getting it's getting time.
Yeah, and you know what's interesting to me, George, is that when you look at geology emerging as a scientific discipline, all of the early geologists, all of those gentlemen from Cuvier, Buckland, Sedgwick, Murchison, right down the line, they were all catastrophists. In one way or another. They were
men of science. They might have been men of faith, like some of the other of their critics. Some
Sedgwick
of the uniformitarians were even men of faith as well.
Yes.
But they rejected that because they were rejecting dogmatic religion at the same time. God bless them. Dogmatic religion needed to be rejected. But they threw out some old stories that had a nugget or truth.
Oh, yeah.
And the rejection of those stories as symbolic of dogmatic religion has continued to this day. Well, and it continues to haunt the subject when I am not a man of the book, particularly. Are you, Randall? I mean, we may have our various faith, but I'm not coming from a place of faith to claim that there might have been an idyllic time that was destroyed by a great flood. And incidentally, I don't believe the biblical flood dates to the YD. I think it's the 8,200 year event, but that's
interesting. That would be worth coming back to.
Yeah. Fish for another platter.
Well, certainly at the time of the early geologists, say even, 1830s to 1850s or 60s, let's say in that window. Okay. Dogmatic religion prevailed, but there was no other than outside of the religious interpretation of Earth history, there was no really geological dogma. And so a lot of these guys going out in the field were basically seeing their first impressions as they're looking at the landscapes. Their first impressions seem to imply catastrophe. And what happened was then, with Charles and Playfair and these guys, they basically were the ones who took the evidence and codified it under the heading of uniformitarianism. And once geology became established as an academic discipline within universities, that dogma of uniformitarianism became the cornerstone of all teaching, like from the 1890s on up until literally the 1980s is the first time it challenged with the Alvarez papers.
And that ideology continues to frustrate hard evidence.
Yes, it does. And I see a lot of the objections to the Younger Dryas impact hypothesis coming as from what I would call self-appointed defenders of the dogmas.
That's right.
And doing everything they can to subvert the evidence. I mean, we have seen what I consider to be almost fraudulent supposed refutations of Younger Dryas data. And this was what was addressed so effectively in Malcolm LeCompte's paper in his group, was he showed how they basically sampled. They took samples at the wrong horizon. And then, of course, don't find the proxies. Well, you don't find the proxies unless you sample the right horizon.
That's right. That was a part of that paper. And also the sampling methodology, which again said is not that complex. And what happened was they were undermining a paper by a guy named Todd Surovell. That was probably the best of the refutations. I brought the one up about the bug poop. I hope some people that read science papers saw through that one right away. But Surovell in 2009 published a paper and said, hey, I went back and looked at my sites and I didn't find it. Okay? He was looking for tennis balls in a barrel full of basketballs and beach balls. You've got to get all the basketballs and beach balls out of the barrel before you look for that tennis ball, much less the golf ball or the marble or the BB.
Yeah, his sieve was too large.
It was. And I tell you, I was at what I guess, if this thing ever is, it was a pretty disappointing moment for us. In 2010, I went out with Dr. Kennett, James Kennett, who's really the most credentialed author out of all the many of us. And
something like 500 papers to his credit.
That's right. That's right. He was known as the father of paleoceanography and writes the big book that you pay $400 for. And we went to Laramie, Wyoming for the Quaternary Association, the scientists who study the last 3 million years. Right. And we went out there in good faith. He had published a critique that said I did not find it. We went out in good faith to discover, exactly how he went about it. He presented to us in the auditorium there in Laramie, and it quickly became Malcolm LeCompte was there, Dr. Kennett was there, Dr. West was there, and immediately became apparent that he didn't size sort. And I hate to be the kind of person, if you go and make an outrageous claim, it does sometimes happen that someone will make an outrageous and incorrect claim. Someone else will make a counterclaim. And then that original person will say, well, you just didn't do it right. Right? You just didn't do it right. This is one of those cases where it truly happened. And you earlier ascribed, and I think it was willful negligence. And I saw that in Dr. Surovell's face in that auditorium when it was explained that he did not do it correctly in the question and answer session. He hung his head and said, I don't have time to go do it again. Fine. He doesn't have time to go do it again. But what he did there, if he'd taken that time again, coordinated, not capitulated, but coordinated with the original scientists and said, here's how we're going to go through it. And let's do this for the good of everybody. We'll take it up, down, or in the middle, but please follow the protocol. Could we do it again? We probably have created some science, or we might have ruled this thing completely out, or we might be on a path of understanding it better. But that didn't happen. It was picked up by the press as a negative. Surovell said he didn't have time, but I still have hopes for guys like him. I think he's a younger fella that's tied to that guy in particular. I think a good guy that's tied to the overkill theory. That his career is based on the fact that the Clovis people hunted him all to death, and good on him there. You know, we need that information too, or we need people that take that view. But how much that influenced his ability to follow the protocols, I don't know.
Well, I would say that the overkill, sometimes called the blitzkrieg hypothesis, was on its way to being discredited within the last 20 to 30 years. We go back to Paul C. Martin in the 50s and 60s, who pretty much took those ideas, which had been around for a long time, and put them together in a system, put them together in a coherent, testable hypothesis, right? Well, his work on overkill became sort of the dominant. And what's interesting and ironic in a way is that when you look at some of those earlier commentators who are endorsing the overkill hypothesis are saying, well, as we're looking at the demise of the megafauna, it seems too catastrophic to blame on gradualistic climate change. So it must have been something completely outsized. The Clovis people sweeping across the Bering Land Bridge, slaughtering pretty much everything in its path, obviously, to affect such a total extirpation of these great species. Which the very first time I ever encountered that theory, I thought, this doesn't make sense. But I think what has happened, from my reading of it, is that idea has been revived within the last decade or so, because we now have extinction has become very much a political hot potato, right?
I couldn't agree more. Yeah, I know where you're heading. Yeah,
you know where I'm heading. Well, this provides Exhibit A that humans have essentially slaughtered, dozens, if not hundreds of species before, and bolsters the case. It does. It gets into the idea that extinction now is a political controversy.
It does. And to say that we shouldn't attribute the last extinction to humans doesn't undermine our responsibility for the current extinction.
Of course.
But it is a convenient narrative to say, and it feeds a lot of the current political narrative that we're at fault for all we do, or for all bad things that happen. It's just global warming as well, and I think we share similar views on that. That I think that negatively influences the debate as well. Now, strangely enough, it's the wonderful dollars that are put into paleoclimatology to go out and study ancient climate based off of our concern from anthropogenic global warming that's going to actually prove that we got a bigger problem than the one that's driving the dollars.
Yes.
And it does not mean that AGW is not a concern for people who don't need to address it. But the way I put it is that the Younger Dryas event, which will ultimately be proven with global warming dollars, that the Younger Dryas event is going to quickly make the driving narrative and the thesis for making those investigations and the argument about them look like we're sitting on the train tracks arguing about the radio station. That we're arguing about one thing that really isn't that relevant if you look at the threat that we're facing over millennial timescale and maybe even a sub-millennial timescale.
Yes.
That we got bigger problems and we need to address those first or in concert with our own damage to the earth.
I have been cataloging, I'll say, events of various scales of catastrophe, looking at what would, let's say, a Younger Dryas level catastrophe do to modern civilization. And I think what we could say is that it would pretty much terminate it. I mean, because you have an event, that might be regional or might be local, but if it's regional or even continental, you have a long period of restoration after that and recovery. But when we look at the Younger Dryas, what we're seeing almost is a succession of things. It wasn't, and this is one of the things the critics have sort of jumped on, is because it wasn't one single event. There was a melting event at 14,005, 14,006. Then there's the Younger Dryas boundary at 12.9. Then there's another extreme melting event at 11.6. Well, these two melting events, of course, require tremendous inputs of energy. This is why I've been kind of considering the possibility of the role of the sun in this whole thing as well, because recent research has suggested that the sun might be vulnerable to the infall of comets. And solar grazing comets now have become a whole new species of comet. And there are hundreds of them now cataloged. They're continuously falling into the sun, and there seems to be a relationship between the infall of sun-grazing comets and solar activity, which to me is
Kreutz sun grazers or whatever.
Yes, exactly. Right. Yes. Well, I think we're just beginning, I think, to appreciate how intrinsically a part of the cosmic environment our planet really is.
Yeah, it's not a closed system.
No, it is not.
I've heard it, referred to. We have the Aristotelian view that we have still have a perfect, like they used to kind of picture things, unchanging ticking clock that we're a part of, that we don't need to worry about, that the clock was almost made for us. And that we are separate from the clock, and people accept today that we have a lot of responsibility for our own destiny in an ecological sense, but they focus almost too much on it and don't realize that we have a responsibility to defend ourselves from what might be a damn mean clock when it hits certain hours.
We have to understand that the history of our planet reveals that it's profoundly dynamic. That's right. Way more dynamic than somebody had imagined a generation or two ago. And part of the problem to me is that the models that we're now looking at in climate change have their roots in the 1988 to 1992 creation of the United Nations Framework Convention on Climate Change and its subsidiary body, the IPCC, essentially who are mandated with the task of proving that humans were causing climate change. Well, that's important. That's important to understand because we are influencing the climate change. However, because it became a political issue, that became the singular focus, right? What you were talking about is that there's this extraneous material that's almost coming up haphazardly.
Right.
Because what we are learning, what we are learning about the climate history of Earth is that it is extremely dynamic and quite frequently catastrophic. And we're only at the beginning of figuring out the multiplicity of triggers. But like you just said, we may have a much bigger concern, for example, than the increase of carbon dioxide by, basically 1 molecule of CO2 for every 10,000 molecules of air.
That's right.
There may be something.
Randall, you just said a climate scientist is attached to the narrative. Can y'all still hear me okay?
Yeah.
Or I thought I hit my mic off. That the climate scientists, for better or worse, it's okay for them now, I think, even if they aren't on a personal mission to ignore data and hype the risk, all of them feel comfortable picking up the phone and telling the reporter it's far more dangerous than anyone appreciates, and this is an emergency. Okay, that is the narrative, better or worse, true or not. Strangely enough, if you call the impact frequency scientists, of which there are far, far, far fewer than even climate scientists who are scarce, if you call the people who are responsible for, evaluating the frequency of cosmic impacts on Earth, their job seems to be to tell you it's not a problem, it's not a problem, it's not a problem.
Yes, it's not a problem. Exactly.
Which is an awkward position for them because they'll both say, unlike the climate, it's not a problem. I do need some more research money. We need to refine this impact frequency better, but it's not a problem. And frankly, without being too conspiratorial, but let me go ahead and go there, that I think that comes from a 1970s Cold War mentality that said anything that was coming out to present a threat that didn't have to do with the Soviet Union is just not something we need to spend any dollars on. And that was a good damn decision. Because we needed to solve that damn threat first. And I think, to some degree we did. We put it behind us. But what did we pick up as the next global threat? The change in temperature of 1.5 degrees C over the next 100 years. Instead of looking again, my God, the sensors that go and record atmospheric booms, as you know, are the same sensors that record the nuclear weapons. That's why they're there. They're to enforce the nuclear test ban treaty, right? Those sensors around the world. They're also the very best devices in the world to reveal atmospheric impacts from regular meteor showers and from right.
And they've done that.
And they are absolutely reluctant to release the data. They actually took it offline a few years ago. They made it harder to get that data, and they only release it in tranches with no explanation whatsoever. For God's sakes, if they pick up something that looks like a nuclear bomb in the Pacific Ocean and it isn't, and they rule that out, please tell me the next day that something blew up above the Pacific that looked like a nuclear bomb, but we ruled it out. And right now, if I remember correctly, it could be a couple of years. They'll put it out. They scrub the data, whatever. But the idea of letting those same systems and techniques and global space technology be applied to this, to true threats, not just, and it's amazing to me the number of missions that do evaluate asteroid threat. And the money that is put into it, it's not as much as any of us would like. But at the same time, they will tell you that there's really no threat. I don't know how the hell they know that. Right. And I don't know why they're spending all the money to look into it when at the same time they're telling you it's not a threat. It's never added up. They're sitting there bouncing stuff off of them, seeing if you can damn affect them with kinetic energy. I mean, pretty soon they'll be painting one white on a side like they say can move it. God knows all the different ways. It's the only natural catastrophe that can theoretically be averted with existing technology.
Yes.
You cannot stop an earthquake. You cannot stop a hurricane.
Volcano.
But the problem with, volcano, exactly. But with the asteroid and comet threat, your problem's picking the different ways to do it. There are a number of different ways to do it. And we do investigate those, but at the same time, so again, not to step in the conspiracy zone, but I've always thought that didn't add up, that we're out there doing the kind of work that we do. And NEO-wise, which is looking at it through infrared, that seems controversial to me. And Nathan Myhrvold, if you go down that rabbit hole, the chief technology officer, a billionaire with Microsoft, was one of the billionaires that came out with Steve Ballmer and Allan, the co-founder with Bill Gates. And there's another billionaire, a guy named Nathan Myhrvold. Hell, he's been tearing their ass off for the last 3 years saying that your impact frequency estimates are absolutely dead wrong. And I'm proving it mathematically. It's been a little bit of and that you're hiding data. There's something going on at NASA, but I've stepped too far there, if you will, because I try to stick with, representing at least some of the stuff that the Comet Research Group has said, which does not include any of those speculations.
Right, but you've got every month we're documenting the cosmic debris flying through near Earth space.
And as you have well documented, it's not the asteroids that are the problem. Although that could definitely happen, it's the comet debris. And that you encounter, as you have taught me a lot about, including Dr. Napier's taught me a lot about, and we both got the science from him, that the Tard meteor stream presents an unusually high, a certain periodicity of dangerous objects that you go across here's how Dr. Napier explained it to me, and you've explained this before, but I don't think it can be said enough, that when we cross that meteor stream every late June and every late October, early November, which my absolute favorite presentation of yours, Randall, is the Halloween Tauren story.
Yeah.
I mean, if that doesn't make your skin crawl and say that these people, the ancients, are talking to us, that there is a rhythm out there, there's a music, that they are absolutely singing a tune to us. And if you tune in right, you can hear it. And what they're saying is something happened. Worldwide, they celebrate that week of death. And then you look at late June, and that's when Tunguska happened. And that's when, that on June 30th. That those two times that we already have a meteor shower that's not the best meteor shower, but it's known for its very bright fireballs, right? That the British neo-catastrophists led by Napier reverse engineered and found out that those two periods each year, it's like us walking across a highway blindfolded.
Yeah.
Now, if you walk across your local highway blindfolded, you're actually going to be okay most of the time, believe it or not. Particularly those times late at night. You're going to be fine from 2 a.m. to probably 4 or 5 a.m. You're totally fine. You'll probably make it through at 10 a.m. to 11.
Yep.
But by God, there's some times where it's absolute rush hour and there are a bunch of fucking trucks out there.
Yep.
You know, and that happens about every 3,000 years, it seems. And there's reason to believe that there was a period of enhanced truck traffic about 13,000 years ago, and we called a bad, bad day. And all of their science is completely separated from the archaeological forensic investigations that are done by the YD team. Now, Dr. Napier, who is a patriarch of that body of science, which just took 40 years for them to develop, he only plugged that in later and became a part of the Comet Research team. He only came in on later papers. He had already proven to his own satisfaction and the satisfaction of the peer reviewers, not proven, but at least provided good enough science to be well published with Victor Clube and others and David Asher for 30 years, saying that you have enhanced periods that we should expect there to be visible bombardments that affected cultural change of human civilization, and we would have expected them to become in this periodicity, and they came from a disintegrating comet 20 to 30,000 years ago, which is progressively broken up, and that we're going into that traffic that it's created.
Yeah. And
you've explained it better than many, Randall. So where do we take it from there, not to retread your ground?
Well, I've been, recommending Clube and Asher and Napier for decades. Actually, early 80s, Cosmic Serpent Brothers, the Cosmic Serpent by Clube and those guys. The British, I've been calling them the neo-catastrophists because they were some of the first really to come fully credentialed scientists who are coming and saying, this is it, this is a real issue.
Right.
Yeah, going back to 1980. And actually they had papers right in that within that bottleneck of 1980 there, linking the KT events, the dinosaur extinction with a cosmic impact. So they were certainly right on the cusp of that.
That's right.
That
they were great thinkers, and they were uninfluenced by NASA.
There we go. Yeah.
I'll just say.
I think I'm going to do a quick screen share here because of what you were talking about, George. I think you'll find that this is rather interesting.
This is Cosmographia, the Randall Carlson Podcast.